Hello everyone, my name is Luke Lloyd and welcome to the Year 5 Block 5 GLA Assessment Homework Review. This is for the maths homework that we've hopefully done this week. So today we're going to go through these tests, tests 3, 4 and 5 in your Let's GL assessment book. Now the way I'm going to do this is I'm going to go through each question, I'm going to give you the answer, and if I think there's any working out that you need, I'm going to write that down as well. So hopefully you might want to just skip through fast forward if you just want to mark it, but this is more really, certainly in terms of explanations, for those who struggle and need a bit of help. Remember, all answers can be found at the back of the book as well, so it might be worth checking those if for whatever reason the explanation doesn't make sense or you need another explanation or different working. Right, let's get started. So, test 3 is the first one we're going to cover, and question 1. Circle the letter next to the correct answer. The correct answer is A, because when we rearrange this equation, if to both sides we were to add 40, we would end up moving this minus 40 and end up with 32 times 56, leaving the 40 behind, equal to 1,752 plus 40. And so by having these two things here, if you look, that is the same thing. They've just swapped it around left and right, and that is equal. So that's your answer for question 1. Question 2. A soup recipe requires 500 grams of tomatoes for every 300 milliliters. She's only got 300 grams, so she has 300 out of the 500. So she's got 3/5 of what she needs. So she's going to need to use 3/5 of the coconut. And if you do 3/5 of 200, you end up, oh, that's a little bit better, 200, you end up with 120 milliliters. And the reason for that is if you divide 200 by 5, you get 40, and she's got 3 lots of that to get to the 120. So that's your answer. Question 3. Figure B shows the path for a remote-controlled toy car. How many points does the car turn through an obtuse angle? An obtuse angle is more than a right angle, so more than 90 degrees, but less than 180. So it's in the gap between these two. So what we have to do is add on the directions it's turned. And here's through the power of computer magic, here's what I did earlier. So if we add these on, you can see in red is the direction it was facing. And I've drawn on the angle it's turned to the new direction. So we have a 90-degree angle, we have a much smaller than 90-degree angle, we have quite a large left turn, we have two 90s. So hopefully you can see the one I've labelled A is the only one where we're going more than a 90-degree turn to go from facing forward to left. And that little toy car means there's only one where we're doing an angle that's bigger than a 90 degrees, but not 180. And I think it's understanding that adding on the arrows of where it was going is the most important step for this one, so you know it was going this way, and it ended up turning that way, and vice versa, turning this way, turning this way, turning that way, and so on. Right, question 3, bit of an interesting one. Question 4. Figure C is formed by arranging and cutting copies of a square and a circle. Each square has an area of A, and each circle has an area of B. Which shows the area of the total? So we've got how many A's? We've got 1, 2, 3 A's. And how many B's? Well, we've got, if I do it in blue, we've got 1 and 2, because obviously these are halves. So we need to have 2B added onto it. So 3A plus 2B is my answer. Question C. Right, question 5. The table shows how many shirts of each pattern are there in a pack of 10. 1, 2, 3, 4, 5, 6, 7, 8, 10, just checking. When Emily picks a shirt at random, what point on the scatter graph below shows the probability that she picks a striped shirt? So first off, what is the probability? Well, it's 4 out of 10. 4 out of 10. That, as a decimal, 4 out of 10. An easy way of doing it might be to say 40 out of 100, which is 0.4 or 0.40. I always like to convert it to a percentage because I know it's an easy conversion then. And that's of course 0.4. So which of these on here is 0.4? Well, the answer is C, because I can see each gap is it's split into 0.1. So that'd be 0.1, 0.2, 0.3, 0.4, and so on. And that's because there's 10 gaps. We want to get between 0 and 1. So that's your answer, C. Being able to convert between fractions, decimals, and percentages, really useful skill. Could speed things up a lot. Question 6. We have a rectangle with a perimeter of 28 centimeters. So the outside, the perimeter is 28. The width is 4. So what then is the area? Well, in order to know the area, I would need to know multiple measurements. So I've got 4 on one side, that means I've got 4 on the other. So 4 plus 4 is 8. So there's 20 left, so that means I have to have 10 and 10. I'm going to take a moment to double check. 10 plus 10 plus 4 plus 4 does equal 28. Good, so I've got the right dimensions. And then, if this was the case, what's the area? Well, it's 4 times 10, which is 40. I've got to remember my units are centimetres squared for area. So it's 40 centimetres squared. D. Question 7. A number is first cubed and then divided by 1,000. The final answer is 1. What was the original number? So I'm going to start with 1. I'm going to times by 1,000, which is 1,000. And then I'm going to do the opposite of cubed, which is to cube root. Cube rooting is a bit more complicated. You have to ask yourself, what number times by itself 3 times will equal it? Slightly easier because it's 1,000, so it has to be the same number 3 times, and the only answer that does that is 10 times 10 times 10 gives us 1,000. So the answer is 10. So the cube root of 1,000 is 10. And I'll write it out again just to show you. So it's something times something times something equals 1,000. And whatever one of those something is the cube root. So that's how you work out. So the answer is 10. E. Number 8. Toby counted the number of packed lunches in each class at Bollow School and recorded the results. What is the mode number? So the mode is the most frequent. So although the most packed lunches is 19, it's not that, it's how many classes, it's the number of classes, so it's the most frequent, the most common. So 11 was had by 7 classes. So the answer is 7 times. So the answer is B, because 11 happened 7 times. So when you counted them up, the most frequent answer was 11. That's the way to think about it. So I asked a question, what was the most common score? What was the most common number? 11 happened the most times. So there you go. I think with this one, the risk is going for either 19 or 7 itself, and it's not either of those because 19 was the biggest number, but it only happened twice. 7 was the number of times it happened, but the number of times what happened, the number of times 11 did. Hopefully that's clear. Question 9. A rucksack contains 400 matchboxes and weighs, oh goodness, 11.8 kilograms. An empty rucksack weighs 600 grams. What is the weight of a single matchbox? Right, goodness me. First thing I'm going to do, I've seen different units, let's convert it all to the same. So I'm going to turn everything into grams. So that means 11.8 kilograms is going to be 11,800 grams. So that's the starting point, that's what I'm dealing with. Then I want to get rid of the rucksack, so I'm going to take away 600, which means I've got 11,200 grams. And then I need to work out now what if that's all 400 matchboxes, I want to work out what 1 is. I'm going to have to divide it by 400. So the way I would do this is I would cancel out my zeros. So now it's the same as 112 divided by 4. And for this, I might do a bus stop, for example. Let's do it. So 4s into 1 don't go. 4s into 11 go 2 times, remainder 3. And 4s into 32 go 8 times. So the final answer, 28 matchboxes. So 28 grams per matchbox. Grams. There you go. Jane writes a sequence in which the first two terms are 4 and 5. She uses the rule below to find the next terms. Multiply the previous two terms and subtract 5. So what's the sixth term? So we have to multiply the previous two and then subtract 5. So my sum is going to be 70 multiplied by 1045. And then to all of that, I'm going to subtract 5. So, bit of a tough one. Let me show you how I would do this. Give myself a little bit more space. Shrink that out the way. I would do this using the lattice method. So for this, I need to draw boxes equal to the number that I have. So I've got 7 and 0. In fact, let's do it. The boxes first. So there's 1, 2, 3, 4 boxes. And then I need to draw lines going across. Really important that your lines go exactly corner to corner. So I've got 7 and 0 and 1, 0, 4, 5. With this, always drawing it larger helps, so I might even make mine a bit bigger because my pen's a bit small. And I'll need to make my pen bigger so I can fit it in. And the way the method works, you multiply each. So 5 times 7 is 35. 5 times 0 is 0. 4 times 7 is 28. So the 10s go in the top and bottom. 0 times 7 is 0. 1 times 7 is 7. So 0 tens, 7 units. And then all of these are all times nothing. So I've got a whole bunch of zeros. Now I add down the columns. So I add a 0, 5, 8 plus 3 is 11, so I carry the 1, put the 1 in. 2 plus 1 is 3, and 7. So final answer, 7, 3, 1, 5, 0. Don't forget I have to minus my 5. So 7, 3, 1, 4, 5. So my final answer is E. Lots of ways you could do it. Column addition, column subtraction, column multiplication. That's fine, but this is my preferred method. But whatever you prefer is best too. Right, that's that. So very quickly as well, give us a score, give yourselves a score out of 10, and let us know how you did. Now with these, I hope you guys are timing yourselves. I think it's really worth doing. So you might have, and I've mentioned this a couple of times, but definitely worth giving yourself a score, what you would have gotten if you did it within the 10 minutes, and also then a score, what you'd have got if you had enough time. So I would do 2 attempts. I would do an attempt to time, and if you didn't finish any questions, I'd come back afterwards and then try and finish them off, and then give yourself a score to time and a score with infinite time, with as much time as you needed. And I think that's worth doing. Let's go through now test number 4. So, circle the letter next to the correct answer. One of these angles in isosceles triangle is 112, and isosceles is one like this, where you've got the same. What's the other? So if this is 1, 112, what are these two angles? Well, whatever they are has to be the same. That's the definition of an isosceles triangle. So I would find whatever's left is 72. Sorry, no, 78. And then half of that will go to each. So I've got to do half of 78, which is 34. And that's using the rule that all the angles add up to 180, and that these two angles must be the same for it to be an isosceles triangle. Number 2. 40 children going on a trip. Each child brings X packets of food. Each child is given Y packets of food at school. What's the total number of packets of food carried by all the children? Well, they've got X that they had from home and Y that they had from school, and that's being times by 40. So it's going to be 40 times XY, and all we would do to rewrite this is get rid of the times and put the number at the front. So that's B. That's your answer. Simplified. Number 3. Graph shows a journey made by Andy. How much distance does he travel on his journey? So this is time, this is distance. So the distance he's covered from here to here is going to be 3, all the way up to here is 12. So he's covered 12 miles to get to here. He rests for it, goes nowhere, but of course he also comes back down from 12 to 0. So to go from here to here is 12, but also to go from here to here is another 12. So that means in total he's done 24 kilometers. And it's because this is distance from home, or distance from wherever he left off from, rather than total distance covered. So he's gone 12 kilometers to get from here to here, and then 12 kilometers to go back home again. Right, question 4. A cotton bale weighs, 331.1 kilograms, 119 grams is sold. What remains? So 331.1 take away 119. And I would set this out like a column subtraction. So I want to do, first off, 0 taking out nothing, because there's a 0.0 here. So I'm still going to have my 0.1 left over. Nothing's going to change that, because 1 take away 0 is 1. I want to do 1 take away 9, but I can't, so I'm going to have to borrow from my 10s. So now I have 11 take away 9 is 2. 20 take away 10 is 1. 300 take away 100 is 2. Final answer, 212.1 kilograms. The answer is A. Question 5, find the perimeter. If I want to find the perimeter, I need to know all the sides. So if this is 15 and this is 4, this is going to be the difference, which is 11. If this whole length here is 11, let me draw it as if this whole length is 11, and this is 6, that extra bit there must also be 4. And now I've got all the sides, so very simply I can add them up. So I'm going to have 15 plus 15, which is 30, and I have 11 plus 11, which is 22, for a total of 52. And if I do just color code them for you, so you can see, there's this one here, and that means this length and this length are the same. So that's where I got those measurements from. There. Right, question 6. How many hours are there from 9 a.m. on a Monday to Monday morning to 9 p.m. on a Friday evening? Oh my goodness. Well, the total amount of time is going to be 4 days to go from Monday to Friday, and half a day to go from the same time in the morning to the same time in the evening. So a total of 4.5 days. Each day is 24 hours. So I want 4 24 hours plus a half, or 4.5 lots of that. That's one way of doing it. And so the final answer is 108. If I was to split it up and show my working, you might do 4 times 24 plus half of 24. So half of 24 is 12. And then 4 times 24 is going to be 96. And that's how you could have got your 108. That could be your working out in your head. Right, let's shrink that. Let's make some room. And that was going from 9. Oh, well, let's not write that now. But it was going from 9 a.m. There's the important bit. Question 7. Figure B consists of 2 identical squares divided into triangles. The area of each shaded triangles is S. Which expression shows the unshaded area? I think we're going to need to do some moving. Well, if I looked, for example, if I was to take this and split it in half and make myself 2 triangles, what I could do, so I just draw them, and I was to move them, hopefully you can see, I sort of moved that up there, and this one there, that would give me 1/8 of the total area. And if I did then the same thing with this one, so if I took this triangle, split it in half, made it a little box, and moved that box down here, it would also take up this area. So if I shunted them to the side, that would then mean I've used 1/4 of my area is shaded. And that 1/4 is what we've called each of them S. So if those that is 2 S's, what's the area of the unshaded area? Well, there's going to be another S, another S, another one, another one. So 1, 2, 3, 4, 5, 6. Lots of S is my answer. And that's just doing it visually by seeing. So if you just work out how much of it is shaded, you could also do it by counting triangles. That would have worked as well. So you could say 1, 2, 3, 4 triangles is shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 aren't. I've gone that way, but I quite like that one. Just in terms of putting everything to the side and working out. So to finish it, 1/4 is 2 S's. So 3/4 is 6 S's. Right, question 8. Which of the following could be a value of y? So the way to read this is you read from left to right, and you need to be able to know the difference between your less than and more than arrows. -11 is less than y, which means y has to be bigger than it. And then we say, so we split into two things. So -11 is less than y, and then we say y is less than 5. So our number has to be bigger than -11 and less than 5. So if I read it again, y is less than 5. So nope, nope, nope. And then -11 has to be less than y. Well, 12 is too small, which means my final answer has to be B. And I've split it up into two bits, two phrases, and I said them to myself. So just to be clear, that's less than, that's more than. And I think of myself as a number line. If I had sort of 1, 2, 3, 4, less than points to the small ones, more than points to the big numbers. But you just got to learn those. What is the order of rotational symmetry of this shape? Cool question. Well, let's see if I can show you. So I made a copy, and I'm just going to hide everything but what we need. So we just need to see the little circle. So an order of symmetry, rotational symmetry, is when you rotate it and it becomes the same shape again. So if I start rotating this, how many times does it match the shape behind it? So if I start spinning it, nope, not the same, nope, not the same, not the same, yes, the same, back to where we started. So the order of rotational symmetry is going to be for this one, one time, because only in one full 360 rotation, only once did it match the shape that it started as. Whereas if you did it with a square, for example, it would match itself 4 times. Every 90 degrees, it would become the same shape again. So there you go. Question 10. So 10 is difficult. With 10, first clue as to what's going on is the fact that the difference is not the same each time. So the difference between x and y is -1, and suddenly it's +1, then suddenly it goes to +5, and so on. So the difference each time is not the same. That means it's not what we call linear, but it's actually called exponential, or for example, quadratic. So what on earth does that mean? Well, if we compare x to y, y is whatever x is squared take away 1. And this to work out might take a little bit of trial and error, but generally speaking, if ever the difference is not the same, it's always going to be squared plus or minus something. So in terms of how to work this out, let's just compare it. Well, y is 0, so we need to have 1 times 1 minus 1 is 0. So for 2, we've got 2 times 2 minus 1, 0. The best clue I can give for this to you guys to find it, if you look, is if you know your square numbers, these are all going to be 1 less than your square numbers. So if you look, you've got, for example, the square numbers should be 1, 4, 9, 16, 25, and so on, but this is 1 less than. So if you've spotted that, 1, 4, 9, 16, 26, the next one should have been 36. So according to our formula, to our pattern, it's going to be 36 minus 1, which is 35. Quite a difficult one, unless you're willing to spot it. I think a lot of you might have started by doing this and trying to work out the difference and seeing it changes. But my general tip is if it's ever changing, if it's not minus 1, minus 1, minus 1, 2, 2, 2, if the change between each one is not the same each time, that's a really, really good clue that it's some kind of squared pattern. Tough question that. I think perhaps listing out your square numbers is your best bet, and then trying to spot that it's 1 off, it's 1 less. So the y is going to be squared minus 1. Square numbers minus 1. Again, guys, give me a score out of 10. Let me know you've done. Right, test 5, last test. Again, it's 10 minutes, so making sure you timed yourself with this. Really important. So, there are 52 cards in a pack. There are 52 cards in a pack. The cards are numbered 1 to 52. One card is chosen at random. What is the probability that it's odd? Well, how many odd cards are there in a pack? Well, half of them. So right off the bat, you could say it's 1 out of 2. But if I wanted to go through and think about it more carefully, I could also say that it's 26 of them out of 52. But eventually, that would simplify down to half. Nice question to start with. Question 2. This regular pentagon is rotated clockwise about its center until it aligns at the top. What angle does it turn through? So we want to make it be turned clockwise until A is at the top. So it needs to go 1, 2, and 3 turns. So that's 3/5 of 360 degrees. Because a full turn would be the whole thing. And 3/5 of 260 degrees is 216. So it's done 3 turns out of total 5 to do the whole thing. Question 3. Which of these is false? So 3/5 is 60% true. We've got 7/20 does equal 35. 3/10 does equal 30. 4/50 does equal 28. And 4/25 does not equal 25. Now, the way I was checking a lot of these, for example, let me pick a nice one, is I'm making them to convert to percentage. You just have to get your fraction out of 100. And if the numbers match, they are the same. So for this one, I'm timesing it by 10 to get to 30 out of 100 is the same as 30%, and so on and so forth. So that's how you compare. But equally, it's worth learning a lot of these so you know. So for example, this one, to get it out of 100, timesing it by 5. So times top by 5 to get 35. And again, for this one, timesing it by 20. So you've got 60 out of 100. And that's an easy way of comparing. Whereas for this one, we should have 16 out of 100, not 15. There you go. Number 4. Cafeteria shows the menu below. Yvonne buys 2 items and pays with £10. So she receives £4.60. So that means she must have paid with £5.40. What 2 items add together to make £5.40? So if you had one minestrone soup for £3.50 and a scrambled egg for £1.90, they add together to make £5.40, and they're the only ones that do. So minestrone and scrambled egg, which is option D. So there you go. So both of those add together to equal £5.40. So, question 5. Richard has 56 stamps. 3/7 of these are vintage. a quarter of the remaining ones are blue. So first things first, 3/7 for 56. Do that, we divide by the bottom and times by the top. So 56 divided by 7 is 8. 8 times 3 is 24. So 24 are vintage. The remaining stamps are blue. So there's going to be how many remaining stamps? That is 32 remaining stamps. And then 1/4 of the remaining stamps are going to be blue. So 1/4 of 32 again, divide by the bottom times by the top, divided by 4 equals 8. Final answer, C. Right, question 6. Charles is facing southeast. Right off the bat, let's just draw one of these for myself. Never eat shredded wheat. Never eat shredded wheat. He can see a house facing directly in front of him and a tree to his right. So never eat shredded wheat. Southeast is down here. In which direction must Charles face that he's facing back to his house? So his back is facing the house. Well, if there's a house directly in front of him, and I want to look in the opposite direction, that's going to be northwest. Much easier, I think, with a picture. Just add a little roof on. So he's currently facing this direction. He wants to face that direction. Paul thinks of a number, squares it, and then divides by 4. The answer is 36. So let's just go in reverse. You've got 36. The opposite of dividing by 4 is timesing by 4. So 3 times 4 is 12, so 120. 4 times 6 is 24. So that's 144. He thinks of a number and squares it, so something squared equals 144. The answer is 12, because 12 squared equals 144. So let's just check. 12 squared is 144, divided by 4, 36. Good. Question 8. The arrow points to the weight of 4 bananas. What would the weight of 6 be? Well, for this one, I need to know 6 equals what, 1 equals what, and 4 equals what. And the reason I go down to 1 is because I can then go from 1 to any number. So I'm going to, whatever it is, I'll divide it by 6, and then I'm going to times it by 4. So I've got a plan of action already. So let's work out what 6 bananas is first off. I'm reading my scale. The difference between each increment is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, 10 gaps. And so going from 250, each gap is 25. So this reads 300. And so now, if 4 bananas is, sorry, if 4 bananas, oh, I've done it the wrong way around, haven't I? This is 4 bananas, so 4 is going to be 300. Shame. So a plan runs array, but it's going to be similar numbers. So to go from 4 to 1, I'm going to have to divide by 4. So 300 divided by 4 is going to be 75. So that means I have 1 banana is 75 grams. And to go from 1 to 6 is 6 times bigger. So I'm going to have to do 75 times 6. And 75 times 6 is 450 grams. So that's A. Question 8. So again, it was just working out that step there, going down to what 1 banana would be, and then going up to 6. Question 9. A family can go on holiday to Costa Rica. The total airfare is 2,100 and the accommodation and food is 700. The day cost of all the day trips is 400. What's the mean cost per person of these expenses? Well, mean, as a formula, is the total divided by how many. In this case, it's the total cost divided by how many people. So let's do the total cost first. So it's 2,100 plus 700 is 28. plus 400 is 32. So 32,000 divided by how many people? Well, in this case, it's divided by 5 people. And if you do that, if we do a bus stop, you get 640 per person. And this is why whenever I'm teaching it, I teach mean as the average. And so what we've worked out is the average cost per person. Number 10. The star below has 10 internal angles. These are the internal angles, for example. I'm going to label them all, but they're the internal ones. How many of these are reflex? So a reflex angle is an angle greater than 180, but less than 200, or less than 360. So less than the full angle. So it's between these two. So 1, 2, 3, 4, 5. 5 internal angles that are in that gap. So there you go. E. Right, guys, that's the homework. Really, really well done. Thank you so much for participating. Just a reminder, if you're reading this, the next live lesson coming back will be on the 25th of April, Saturday the 25th, and throughout the week preceding, and there'll be I'm sure, our normal schedule throughout the week. So if you can't make that Saturday, I'm sure you come see us on one of the following days throughout the week. But have a wonderful Easter. I'm sure you've worked really, really hard. Very well done. Make sure you have a really well-earned break. And don't worry, again, remember, by doing this homework and marking it now, you won't be doing the week 3 homework until you've had the week 3 lessons. So you've got a lovely Easter ahead of you to fill with relaxation and hopefully some lovely fun and family games. Brilliant, everyone. Thank you so much. Looking forward to seeing you on the live sessions when we resume. Bye-bye.